several power generation plant have to continuously give their load to fulfill the demand, constant demand. Okay, so what is the main power plant, guys? With your knowledge, what is the main power plant? I think you thought that. Is it a hydro? Is it hydro? No. Preventive maintenance throughout the year. What happens? What happens? Yeah, there will be a lot of failures, right? There will be a lot of failures. So that's why coal power plant there are a lot of failures, right? There are a lot of failures behind the coal power plant because it works continuously throughout the year. Okay, so it is the best power plant in Sri Lanka, guys. It is the best power plant in Sri Lanka, the coal power plant, and it's a very efficient power plant. It's a very efficient power plant. Okay, so because it's the rated power is rated power equals 900 megawatts, and if when we use three machines, there are three machines. Okay, each one have 300 megawatt. If we use three machines with the best coal, we can get 900 megawatts. Okay, very efficient power plant. But the thing is, power plant has to work throughout the year, okay, without any maintenance. That's the issue. Okay, that's the truth behind the coal power plant, Lakvijay coal plant. Okay, and other thing, what is the low cost power plant in Sri Lanka? Low cost power plant. Guys, what is the low cost? Lowest one? What is the lowest one? Generation cost? Lowest generation cost. Yes, it's hydro, right? It's hydro. The second one? No, it's not the diesel. What is the second one? What is the second one? What is the second lowest cost generation? First one is hydro, definitely. Yeah. Second one, it's coal. It is coal, right? Coal power plant is the second best low cost power plant. Okay. So why we can't make another coal power plant? Yes. Why we can't? Why we can't build another coal power plant? So why we can't? What is the issue? When we comes to hydro power plant, CB have several large hydro power plant, and there are a lot of mini hydro as well. Those hydro power plants controlling by another private companies. Okay, CB subsidiary companies. Okay, so now in Sri Lanka, hydro power plant almost has saturated. Okay, almost has saturated, but we can build another coal power plant, right? But there is an issue. What's the issue? No, we can import coal from India, right? From India. So what is the issue? And Singapore. What is the issue? The issue is, right? I can't remember the year. There was an act, World Act, because of the carbon emission, the money, right, or sponsorship to make the coal power plant, we can make the coal power plant for our power crisis, right? Okay, so that is the issue, or else we can make the coal power plant. Okay, in India, 2022 and 2023, 2022, they built another coal power plant, right? So if we have the low cost electricity, right, low cost electricity, we can get many sponsorships, right, for the manufacturing companies. The issue is right? We have low labor cost, right? We have low labor cost. Normally, South Asian countries have a very low labor cost. India, Sri Lanka, Bangladesh, right? We have very low labor cost, but the electricity cost is very high in Sri Lanka, right? So if we can reduce the electricity cost by using the low cost generation, okay, we can take more manufacturing companies, especially vehicle and other electronic device manufacturing companies, right? Because we have technical knowledge, right? We have technical knowledge, we have engineers, we have best universities, but we haven't the low cost electricity. That's why can't get the sponsorship or any other collaborations with manufacturing companies, right? Okay, that is the reason. And guys, now at the moment there is a war, right? So within next 2 weeks, Sri Lanka has to face a large power crisis, right? Because of what? Because of the diesel and the petrol, right? Because of the I think we have only petrol only for 1 or 2 weeks, okay? And diesel, without diesel, what happens to the power plants? All the power plants, except the hydropower plants, all other power plants, we want diesel to the startup, for the startups, right? For the startups, coal power plant, even coal power plant, we want diesel for the startups to start the machines. Okay, generators, we have to start the generators. To start the generators, we want diesel, right? What happens without diesel? Even we can't start the coal power plant or any other diesel power plant. Then I have to go the 2 years back. What happens? I think 2 years back in the corona period, there is large power cut, right? There was large power cut, 12 hours. I think it's 12 hours, right? Finally, we have to cut the power for 12 hours, right? 12-hour power cut. Maybe within 2 weeks, what happens? Maybe, right? Within 2 weeks, we have to go to power cuts, right? Because of the power crisis. Okay, so okay, that is the thing. So I will go my session. This is for the industrial safety, not the generation, right? Okay, so this is the content that I plan to cover: the domestic electric supply and electrical hazard. Then what are the protection that we can use to prevent the hazards, right? And then I am going to give a basic idea about the IET regulation and stand. That's the electrical installation regulation and stands. Okay, so and what are the basic maintenance? Fine. Okay. Okay. So this is the way from power generation to the consumer end. Okay, so we have several generation station: hydro, coal, and diesel, and there is a transmission. So in Sri Lanka, what is the transmission voltage? I think you guys don't know, right? Transmission voltage. No, I know you guys. You don't have to know, but the transmission voltage 132, okay, kV. This is not in Sri Lanka. So then we have to use two transformers, one for the step up and another one for the step down, right? For the customers, there are three customers, right? There are three consumers: the large industries, and the small industries, and domestic users, right? Domestic users. So for the domestic users, we'll get 230, right? 230 voltage. And if we want we can request for 450 volt, 15 volt, right? 415 volt, it's 3 phase, and single phase 230, right? And for the small industries, they need 11 kV, and the large industry, they need 33 kV or more. Okay. Okay. So when we come to domestic electrical installation, this is the installation, okay, and the basic installation system, the domestic electrical installation systems. So there is a distribution wire and the supply cable. I think you guys have seen, right? Have seen the supply cable, distribution wire, and service fuse, right? Service fuse and electrical meter. Okay. From the distribution wire to electrical meter, and yeah, from A to D, those 4 equipments are owned by the CEB. We can't maintain those 4 points, right? Distribution wire, supply cable, service fuse, we can't maintain, right? So if we want to maintain, we have to request from CEB. Okay. So then the electrical meter is also for the CEB, and main switch RCCB. I think you guys have seen the main switch, right? What is the normal word? The common word? It's not the main switch. What is the common word? What's the normal? We normally call what? Yeah, it's strip switch, right? Strip switch, and RCCB and MCB. Then H switches, right? The switches and plug sockets, rectifier and light bulbs. So those are the main basic electrical installation equipments. Okay. Then I will go to next. Okay. Then when we comes to electrical hazards, we can take the electrical hazard in 3 ways, right? Electrical shocks, arc flash, and the fire hazard. I think fire hazard, it's normally fire, right? Because of the electricity shorts, and arc flash also like a fire. Okay, I will show the video for the arc flash and blast, and electric shock. Okay, so the electric shock, this is the most common hazard, right? Electric shock is the most common hazard. Okay, so I want to ask another question. Before the question, okay, so okay, this is the way that electrical shock happens. Okay, so I think you guys can see, right? You can see. So he just only touch only one wire, right? Only one wire by using his 2 hands, right? By using his both hands. Okay. I will explain the electrical shock. Okay. Before that, this is electrical arc flash. Okay. This is the kind of arc flash. Okay. The transformer arc flashing. Okay. Now I want to ask a question. So what's happened when we touch a live wire by using one hand? What's happened? There is a exposed live wire, okay, without any insulation. There is a exposed live wire. So what happens when we touch using one hand? What happens? Is it make an electric shock or not? Yeah. 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 Exactly. Yes. So if we have a contact with the ground, right? If we have a contact with the ground, what's happened when we touch only one exposed live wire, current can going through our body, right, to the ground, from the live wire to the ground. If we have no any contact with the ground, what's happened? I mean, when we use the large rubber shoe or something, then what's happened? There is no shock, right? So when we touch live wire, exposed live wire by using both hands, then 2 points, we use both hands, what happens? Is it make a electrical shock or not? It's make. What's happened? It can make, right? It can make. It can make if there is the large voltage difference. Okay, if there is a large voltage difference, okay, so it can make an electric shock. If there is not, it cannot make, right? It cannot make electric shock. So it means to make an electric shock, what is the main reason behind that? Behind the electrical shock, what is the main reason? Current or voltage difference? Yeah, it's voltage difference, right? It's the voltage difference. So if we have a voltage, if there is a voltage difference, right, it can make the electric shock, right? If we touch that voltage difference, the current is going through our body, right? To make the electrical shock to the human. Okay. So next question: can all the electrical shock make life damage? Can all the electrical shock make the life damage? I think you know that one, right? Can. It can't be, right? So what are the variables? I mean, what are the things that behind how it happens? All the electrical shock cannot make the life damage, right? So what is the theory behind that? What kind of electrical shock make the life damage? What is the reason? I mean, I will give the example. So 10 ampere. Okay, 10 ampere. A person exposed 10 ampere current throughout 0.02 second. What happens? What's happened? And there is another person, he exposed only 2 ampere but 10 minutes. Let's say, for example, what happens? What is the difference between those two persons? One person exposed 10 ampere 0.02 second and another person exposed 2 ampere throughout 10 minutes or 30 seconds, let's say. What is the difference? What is the difference? Yeah. What situation can make the life? I mean life damage. Probably one. Second one. The second one can make or can't? It can, right? It can. It's the small current, but large time, right? Large time. It can make the electrical shock. There is a diagram and there is a, I will show the diagram. Okay. Can you see? See. So this standard, right, is a IET stand. This is 0.1 milliampere time 5 seconds. There is no effect, right? There is no harm. So see what happens. 10 milliampere 2 seconds, right? This is the margin. It is the margin, right? It's the margin. So if some person expose then 10 milliampere then 2 milliseconds, sorry, 2 seconds, what happens? It can make damage, right? Can make damage. And 1 ampere, if someone expose more than 1 ampere, then what happens? There is no time, right? There is no time range, right? 0.01, someone exposed more than 1 ampere can make the life damage, right? Life damage. And there are a lot of okay, so that is the theory behind the electric shock. And I want to show one video. This one. This is I think this is in India, right? It's in the India. It's arc flash. Okay. There is the arc flash. There is no hazard. Okay. Yes. Okay. So there is no. Yeah. Yeah, this one. Okay. Guys, there is 2%, right? There are 2%, sorry. There are 2%. See what is he doing? See, what happens? I think you guys can explain that one, right? Myself from medical faculty. So what happens to the second person? Sorry. See, I think first person almost done, right? See. Okay, can someone tell me what happens? Yes, exactly. Yeah, it's because of the muscle, right? Electric shock can impact to, I don't know exact word. I think you guys know, right? The muscle is a damage, no, right? It's not a damage, right? What happens? It's not a muscle damage, right? It's maybe I don't know the name, but he knows, right? Yeah. Okay. So, okay, next one. See. Okay, this is very common. Okay. Okay. That is happening. පොඩි කාලේ කියනවනේ ඉලෙක්ට්‍රික් ෂොක් එකක් වෙච්චාම ඇලෙනවා කියලා. අහලා තියෙනවද? කරන්ට් එකක් මොකද්ද අපි ඒකට කියන්නේ? සාමාන්‍යයෙන් පොඩි කාලේ කියනවා අපි ස්විච් එකක් ඇල්ලුවට පස්සේ කරන්ට් වදිනකොට එයාකට ඇලෙනවා කියලා. ඇයි එහෙම වෙන්නේ? What is the theory behind that? This is like, this is a kind of, right? See, he can't remove, right? He can't remove that. Why? What is the reason? Sorry?
There is involuntary muscle contractions.
Yep. Yep. Yeah. He explained that in medical words, right? It's okay. Yeah. Yeah. It's the way. Okay. So, yeah. So, and there is, this is also arc flash. So we can't prevent this arc flash. So what we have to do to prevent the arc flash? Next topic is preventing those electrical hazard. Okay, to prevent these hazards, what we have to do? This is arc flash, right? Arc flash. So okay, those are the common electric hazard. Okay. Okay. So what are the things that we have to use to prevent from all the electric hazards? Electric shock, electric flashes, what we have to do. I think for the electric shock, to prevent the electric shock, we can use several equipments. Okay, normally in the electrical installation, when we are doing electrical installation, we use those electrical equipments, okay, protection devices, to prevent the electrical shocks, okay, and especially without any life damage. Okay, number one, to prevent the life damage, right? Life damage. Then we have to protect the equipments. Okay, the first one is the life. The second one is the devices, right? There are a lot of very costly devices in the industry. They are using very costly devices, right? Very costly devices. So they have to protect the devices. And the first one, the very important one, is we have to protect our life, right? So there are a lot of protection devices, electrical protection devices. As a basic protection, normally we use insulation material, right? There are a lot of insulation. There are a lot of cables with the insulation materials. Okay, when someone touch this cable, there is no electric shock. Yeah, right. So there is no electric shock because of the insulation layer. There is an insulation layer. It's depend on the current. Okay, all the layers are normally it's not equal, right? Not equal layer. I mean the layer density is not equal. It's depend on the current rating. It will depend on the current rating. There are communication wire, there are current wires, and all the wires we have to use the insulation. It's a basic protection. Okay, and the fall protection devices, normally for the all fall protection devices we use the common residual current devices, RCDs, residual current devices. Okay, it's a very technical word. Okay, it's a very technical word. And RCCB, normally trip switch, right? Trip switch and earth fault relay and the RCCB, I think yeah, the both are doing the same job, right? Same job in the electrical industry. Normally in the industry we use earth fault relay. In your domestic electrical installation, in your homes and other domestic electrical installations, we use RCCB, and normally we use the MCBs, right? Are there any panel? No, right? There is a panel. I don't know. Yeah. Now there is a RCB, RCCB, and there are a lot of MCBs. Okay. Now you can see. After the session, you can see it. Okay. There are some MCBs and 3 RCCB, the large one. Okay. And the other overcurrent devices, molded case CB, air circuit breakers, in domestic electrical installation, we have 2 cables, right? The single phase supply. Yeah, RCCB, it's normally, yeah, RCCB, it's normally monitoring the current difference from the live phase to neutral. The equal current going through the live and the neutral, right? There is no difference. Okay, if there is a difference, what happens? If there is a difference, RCCB can monitor the difference. Okay, what happens when we touch the live wire? When we touch the live wire, the current going through our body, not the neutral, going through our body, not the neutral wire, right? It means it make a current different, right? Current different between the live wire, and the neutral, because we touch the live wire and current going through our body. There is no current going through the neutral wire, right? There is no current going through the neutral, so there is a current difference between the phase wire and the neutral wire. Okay, so RCCB can monitor the difference. Okay, according to the RCCB difference. Okay, according to the RCCB rating, it can trip, right? It can trip the circuit, right? It can trip the circuit. and that is the job, right? That is the job that RCB have to do. Okay, and okay, so so what? Okay, so we can use RCCB to protect electrical shock. Okay, especially the live wire. Yep, because of the live wire, exposed wire, we can use that RCCB to prevent that issue. And there are a lot of, yeah. Wow, okay. So what is the main limitation of the RCCB? And the other thing, why we have to use MCBs. MCB. I think you can see in your houses, there is large one RCCB and there are a lot of MCBs, right? 2, 3, 10 or more, right? There are a lot of MCBs. So if RCCB can prevent all the shock situations, why we need to use MCBs? If the RCCB can prevent all the electric shocks, so why we need to use MCBs, not MCCB? Why we have to use? Guys, so let's say, so there is a equipment. For example, there is a equipment. The current rating equals 10 ampere. Okay, so what happens? There is 15 ampere current going through the equipment. Then what happens? The rated current equals to 10 ampere. There is 15 ampere current going through the equipment. Then what happens? It make what? What happens? What happens? So we call that situation as a overload condition, right? Overload condition. So it can make a lot of arc flashes and other electric shocks, right? Electrical fire, right? Fires can make, right? So we call that situation as a overload condition. Okay, so in that condition, it say the rated current equals 10 ampere and 15 ampere current is coming through the live wire and going through the neutral wire. There is no current difference between live and the neutral. Okay, there is no current difference, but the current is higher than the rated current, right? The current is higher than the rated current, but there is no current difference between the live wire and the neutral. Then RCCB, what happened? It can monitor. It can't, right? It can't be different. So that's why we have to use MCBs. Okay, so we normally use MCB for the overload protection, okay, and short circuit protection. There are two MCBs: thermal protection and magnetic protection. So normally, I think you guys have known the biometric strip, right? Biometric is what the word here. Those kind of mechanism inside the MCB, right? So that is the way that MCB can prevent the overload condition. Okay, overload condition. So overload condition can make a lot of electrical shocks, electrical hazard, electrical fire, those kind of things. So I think, okay, this is MCB curve, very theoretical one, right? Very theoretical one. I am not going to explain this one. Yeah, it's very technical, right? So this is the MCB ratings. Okay, so normally it's depend on the MCB rating, depend on the current and the time, because of the biometric strip. Okay, normally it's working with the heat, thermal heat. So because of the thermal heat, there are two variables, right? Current and the time. I'm not going to explain the part of behind this curve. Okay, so next I'll move to the IET wiring regulation. So this is the regulation, this is the stand, okay, the world recognized stand for the electrical installation. Okay, the thing is, so we have to follow this IET regulation when we are doing any electrical installation. Okay, not we, someone has to follow when he or she doing some electrical installation, he has to follow. The thing is, in the industry or especially in the domestic electrical installation, are they following this IET regulation? No, right? Even they don't know, right? Even they don't know. That's the issue. Especially in domestic electrical installation, you guys can check, right? You guys can check easily. You can check when you are going to home. You can press. There is a button inside the RC, the main switch. There is a button. If you press that button, okay, if you press that button, main switch has to trip. Okay, you can check. You can check when you are at home. So most of you, okay guys, you can check. Then normally, if it's work properly, when we push that button, the main switch have to trip, right? Have to trip. So you can check whether it's trip or not. Okay, so that's why in Sri Lanka, especially domestic, there are a lot of domestic electrical hazard. Okay, because they even don't know the IET regulation, right? Okay, so that's the thing. So there are a lot of things inside this regulation. There are wiring regulations, so we have to choose the wire according to the regulation. They mention the current rating, voltage rating, blah blah blah. There are a lot of things. We have to check before we do that our electrical installation, especially in our houses. Okay, normally for the industrial buildings, I have to guideline to test the electrical system, design the electrical system, then implement the electrical system. There are a lot of guidelines. Okay, there are a lot of guidelines. This is a international stand. Okay, so okay, those are the key topics covered by the IET regulation. So you can see they have earthing regulation, RCCD, the electrical RCD regulation, residual current device regulation, including MCBs, MCCBs. There are a lot of protection devices. And okay, Sri Lanka, there are a lot of earthing system, TNS, TN, TNCS, TT. I think you guys don't know, right? You know, yeah, you should know. Okay, so in Sri Lanka, we use TT system. Okay, TT earthing system. It means in generation N, CB has to earth. Okay, they has to earth. Okay, and in the customer N, we have to earth the system. Okay, normally the basic theory behind the TT system is in the generation N, CB have to earth the system using earth wire, right? Maintain. So in domestic electrical maintenance and any other industry or any other thing, any other electrical installation, we have to do the proper electrical maintain agenda, right? We want that one. So normally the basic one is visual inspection, right? So normally according to IET regulation, they mention visual inspection for the industrial buildings, right? For the industrial building, we have to do visual inspection twice a day, okay, for the industrial building. visual inspection. The IET regulation, according to IET regulation. So we have to check whether there are damaged cables or any other sockets. Okay, so we can prevent the shock, not the shock, electrical arc flash, those kind of hazard by using the perfect visual inspection methods. Okay, so then testing and troubleshoot, this is preventive maintenance one. Okay, normally we have to do the testing before the implementation of the electrical installation, and after the implementation we have to do the testing, and after some time period, let's say 3 months or 6 months, according to the machines, according to the equipment that we use, depend on the equipment. Okay, normally we use 3 months, right? 3 month period to do the testing and troubleshooting, right? For the RCD, they mention, okay, I mentioned this button, right? Test button. So normally we have to follow the testing and troubleshooting every 3 months, right? For the RCD, residual breakers. Okay, so this is the maintain process, basic maintain process, and according to the regulation we have to make the maintaining process, right? Maintaining agenda according to the regulation and according to the equipment that we are going to use, right? And the system, what is the system that we are using, right? Okay, then, okay guys, any questions? Oh, any question with the electrical installation or the generation systems or any other power crisis or anything? Yeah.
So is there anything else we can do to test the, I don't know, test the safety of the wiring systems in a house other than pressing that test button and see if it works?
Yeah. Yep. So, yeah, it's valid question, right? So, who is going to do this maintenance, right? Who is going to do, because I know the procedure, right? I know the procedure, but you guys, I don't know, right? The procedure. So, who has to check? Who is the person that we can use to check this one, right? The especially maintenance, right? For the electrical maintenance. So, I mean, for the domestic installation, we can get support from the CB or distribution company. I mean, in the coastal area, I think you guys have known, right? So for the coastal area, the distribution system is handling by the LECO, not the CB, right? In the other areas, the distribution system is handling by the CB, right? We can request maintenance from the CB for the domestic, for the our distribution system. We can request because we don't know the procedure, right? We don't know the procedure. We can't go through the IET regulation. Yeah, exactly. We can't, right? I can, but you can't, right? So yeah, we can request the maintain from the CEB, and there are a lot of agencies, right? There are a lot of agencies, and there are a lot of electrical installation companies. They give the support to maintain our domestic electrical installation. Okay, actually we can take the support from them. Okay, they normally they comes to our house, and they have lot of equipments. They have a lot of digital meters, digital equipments. They can easily find issues and electrical. They can normally we have to call them, and we have to request them to do the maintenance for our domestic electrical supply. And industry normally they have one or two electrical engineers. They should have one or two electrical engineer, and he is the responsible person for that, right? He is the responsible person for that. And yeah, okay, any other questions?
One of the questions that I have is, now when we are plugging in our, let's see, the charger,
Yeah.
there are sparks or
Yeah.
sometimes. So one question I have is that threatening for us,
Yeah.
and why is it happening? Whatever.
Okay, so yeah, it make a damage, right? Yeah, it's make a damage. So normally there are two points behind that. The one is because of the loose connection, right? Because of the loose connection there is a spark. Okay, so because of the loose, yeah, it's the main reason. Main reason is the loose connection, right? We have to tighten it. We have to tighten it, or we have to use, we have to change the plug point, or we have to tighten it. Okay, if that happens because of the loose connection, that is the solution. Or else it can happen because of the overload. Okay, for example, you have I mean extension cables, right? Extension sockets. There are 10 sockets. In the shop you can buy 10 socket one, 11 socket one, 13 socket one. They can sell anything, but you can't use 10 socket at one time, right? It can make an overload condition. Okay, so that is the second reason. Okay, that is the second reason. So when you buying the 10 or any number of socket, you have to check the ratings, right? You have to check the current rating, but you don't know the ratings, right? So in the shops, what they are doing is they use small wire, maybe 2 ampere, 3 ampere, 5 ampere wire, but they made 10 or 20 sockets, right? Sockets. So it make a overload condition. Okay, when you are going to plug your phone or any equipment, can make a flash, short circuit, the connection issue. Okay, so those two are the main reason for that. Okay, so you have to check the connection, whether it's loose or not, and you have to check the overload condition. Okay, so you can remove several plugs and you can plug the equipment that you want, right? Only. Yeah. Any other questions?
Is there anything that we can, like the protective measures that once you mentioned, if we are wearing rubber shoes, there won't be an electric shock. Other than that, is there anything that we can sort of use as preventive measures for at home in daily life? That's one thing. And the other thing, as it's shown in the video, if we got that muscle spasms and all, if one of our family members fall down with a shock, so what should our immediate action be?
I think that question I want to ask from you, right? Okay. Okay, guys. So I will ask question before answer you. So I think 1 year before, so the regulation changed the shape of socket, right? Is it? Socket එකේ shape එක වෙනස් කරන්නේ ඔයාලට එක මීටරද? There is a, I think now there is a square shape, right? Square shape. The previously we had the round one, right? Round one, right? So Why? What is the reason? What is the reason? ඇයි එහෙම වෙනස් කරේ? මොනවා හරි කරන්න ඕනින්ද? Why? What is the reason? Huh? No, there is no round one now. In the shop, there is no one. Why? They mentioned two reasons. The first one is the babies can put their fingers to inside the chocolate. That is the main reason they mentioned. The second one, the round one can make more leakage, right? Can make the more leakage than the square one. I think they did the research. Okay, I don't know. Maybe they did the research and they found the round one, the round socket, can make more leakage than the square one, right? That's why they changed the socket shape of the socket to round to square, right? And so, how do we prevent the domestic electrical shocks? She asked, right? How do we prevent? We can wear a rubber shoes, right? Okay, right? It's a basic one. So, how do we prevent? What are the things that we can follow? Normally, there are a lot of things, right? There are a lot of things. The main thing, so what is the place that most, the mostly people can get electrical shock? What is the place? What kind of place? Normally? Yes, exactly. Why? Yeah, that is the reason, right? The kitchen or washrooms, right? So for the kitchen and washroom, we have to use not the same sockets. Okay, there are specific sockets. There are specific sockets, especially for the washrooms and kitchen. Okay, guys, anyone have seen this one? Special sockets? No, right? Why? What is the reason? Is it your issue? Is it your problem? There are a lot of special sockets for the, especially for the wet walls, those kind of things, right? There are a lot of wet walls, the washrooms and kitchen. So there are a lot of special sockets, especially for that points. They point out the place, but we don't use that socket. Why? No. Actually, do you know that socket or have you seen? No, right? Why? Is it your issue? No, I mentioned that, right? The person who are doing that electrical installation, actually they also don't know. That's the issue, right? That's the issue. So actually you should have small knowledge about the domestic electrical installation. Okay, you have to know. That's the thing. You have to know whether you are a doctor, maybe any other person. You have to have small knowledge about the domestic electric, especially for about your house, right? Not the industry. You don't want to know industrial electrical installation, right? It's not your subject. But you have to know the electrical equipment, what we have to use at that point, right? They point out the place, so you have to use that socket. Yeah, small children and elder peoples, right? So we have to give the special what is right? So with the babies, their activities, they are doing many activities with the electric equipment and those kind of things. So we have to consider those. So I think those are the things that we have to follow especially in the domestic electrical installation to prevent our domestic electrical shocks. Okay. The other thing, what is the other question? Ah, okay. So that question I think I have to ask from you guys. What I have to do? What I have to do after facing a electrical shock? Especially, she mentioned the muscle, not the life damage, right? The medium level one. What's the thing? In my opinion, I have to find a doctor. Okay. My opinion, we have to find a doctor. Okay. So, what's your opinion? Yes. What I have to do? Okay. So that is the main thing that we have to follow first. Right? Then, according to my opinion, we have to we have to take him and go to the hospital. Okay. So the first we have to follow the process, and we have to check whether he continuously touch that exposed part, right? So that is more important. Otherwise, what happens? We also have to face the electric shock, right? So that's the main thing. Okay. Any other thing? Yes, I will ask the last question. So, guys, how do you face? How will you face? Right? How will you face the power crisis after this week? What is your opinion? What is your honest comment? How will you face? Before that, are there any questions? Any other question you can ask? And no question? So I have two questions. One question, after 1 week, how guys you are going to face, right? How you face that the power crisis? And next question, after 5 or 6 years, and where we are, Sri Lanka. Two questions. The last question normally I ask when I went to the when I go on any session, I will normally ask after 6 years, where we are, where we are. So, guys, how we can face the power crisis after 1 week? Sorry? Okay. Okay. Any other comments? What we can do?
We okay. Alright. So we basically had like 2 truck batteries at home, and then that would essentially like charge up during the time we have power supply,
Yeah.
and then when there's a power cut, we can't use like I don't know.
Yeah.
So that might
So,
go
yeah,
for
it's good option, right? So we can use solar, right? Off-grid solar, not to connect to the grid, and we can directly connect that solar to the battery, and we can charge the battery, and we can use the battery to for the only for the essential loads, right? You mentioned that, right? Can we use the only renewable? Can we use total renewable for our demand? And nuclear power plant, can you make a nuclear power plant? and use the nuclear power plant. So why?
One, from what I know, you essentially need like a large area without like people in the vicinity.
Hmm.
I'm not sure if that's like a prerequisite, but the other thing is I don't like really trust maintenance and so I'm like if they're not
Okay.
really doing anything properly for like
Okay.
coal power
So
plants, it would be
you don't
catastrophic.
trust me, right? Okay. Basically, electrical engineers, you don't trust the electrical engineers. Okay. Okay. Yeah. 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 I also have doubt with that maintenance, right? Yeah, because we have to uh, go the very deep maintenance, right? Very deep maintenance process. If we made the nuclear power plant, yeah. In your opinion, yeah, it's correct. It'll be, but according to my opinion, we can make, right? We can build very small nuclear power plant, very small one, very small one. There are technologies, right? And the SMR, the small modular reactor. I think you have watched that movie, right? The Chernobyl, maybe. Okay, so yeah, we have to go the very deep process, and we want yeah, there is the knowledge gap. Yeah, maybe. Just, but in my opinion, it's possible. It's possible, but I don't like to trust the politicians. That's the main issue that I have. Okay, not the engineers or the knowledge and the things. Can't trust. Don't like to trust the politicians. That's the issue. So okay, so it's possible. One reason. Sorry, it's possible one thing, and the solar is another possible thing for the power crisis, and coal power plant. You can make the coal power plant very easily if you have money. So yeah, we can take a sponsorship. So now I think we have the good chance, right? We can easily connect with the India or the China, right? Can easily connect. We can easily connect with the India or the China at the moment because of the war, right? It's the very easy way. It's very easy thing. So then we can take a sponsorship from China or India. We can build a coal power plant. So can be, and yeah. So the last question is, what is your opinion after 6 years? Where we are? After 6 years, you guys are maybe no, not. I mean the country. Maybe to win the country, not you guys. You. So what happens to the Sri Lanka? What happens to Sri Lanka? Then I wrap it up the session. So that is my last question. Okay. What's your opinion?
I believe is the problem is creating that basal electricity, that the coal power plant is doing. So we need something that is efficient and that can create that 900 at least. So what I believe is the solar power, from my knowledge, I don't think it's adequate to cover up that peak at the night. So, and I think the wind didn't work out as well.
Yeah.
And then we have tidal, I don't think that is reliable as well.
Yeah.
So, the petroleum, the diesel ones and
Yeah,
the
that
coal
is the
will
issue.
run out
Yeah.
at one point. Well, if that happens, then the nuclear plant is the only option to go.
Yes. Yeah, yeah. Very logical answer, right? Yes. Very good. So yeah. So we have to think about it, right? So solar definitely can't, right? Especially, for example, night peak, definitely we can't, right? The wind, no, yeah, that much of power, yeah, it's cannot. And tidal, no. So the diesel and other petroleum fuels, almost done, right? Almost done. And next, so only one thing, right? And so there is another thing. So we can take power from India. So the, that is the solution now at the moment government is following. Okay, they are talking with the India and I think they are going to take power from India because there is a nuclear power plant near to us. Okay, there is a there is a nuclear power plant. I don't know, some politician signed that agreement and I don't know who, someone. Okay, he signed, and there is a nuclear power plant, and we can take power from India. Okay, I think that is the most possible solution instead of the nuclear power plant, right? When it comes to nuclear power plant, yeah, you mentioned the issue, maybe. So we can face that issue, maintaining issue, and there are a lot of other, the especially from the society, right? Especially from the society. So we have to do a lot of social the knowing program, right? So from the society side, definitely we have to do that one, right? So yeah, and then when it comes to nuclear power plant, we have to face that issue. So the possible thing is we can take the power from the India and by using the agreement. So at that point also, I have to one the issue with the, yeah, politicians, right? It's depend on the politician. So yeah, okay guys, I'm going to wrap it up the session, and okay,
Just
that's it.
one last question.
Yeah, sure.
So I'm just being curious. So I have heard like when we are using the electrical appliances, it's better to directly use the wall socket instead of using that extension cord. So is there any significant difference between the two methods, or else what's the most suitable way to do that?
Yes, most suitable way is, so if we can use direct socket, it's the best one. Okay, without any extension cord, because the manufacturers don't follow the current rating or voltage rating or anything. Okay, they just make the extension cord, and if they can put 100 of switches, they definitely put that socket, right? So but if you can use the direct socket, it's the most the best one. The best one is we can use this socket. Okay, so but we have to use the extension cords, but yeah, I prefer the direct socket. It's the best one, right? So or else we can take some I mean the, the reputed companies, right? There are a lot of reputed companies, so they have made some extension code, and if we can use that reputed companies one, it will be better. Okay, okay, it's okay, right? Okay, thank you very much.
So as we come to the end of this session, I would like to take a moment. As we come to the end of this session, I would like to take a moment to thank all of you who came. And first and foremost, I would like to thank our resource person, Mr. Sittija Ratnayaka, who shared his valuable knowledge and practical insights with us. Your session truly increased our knowledge regarding electrical safety, and I would like to thank Mr. Kavindu for coming today. And I would also like to thank our members, President Ashwini, Vice President Pamoda, our Treasurer Oshada, Secretary Amiru, for your continuous help. And I would like to also thank our administration, including Dean, our Senior Treasurer Priyanka sir, for their support and guidance. And most importantly, I would like to thank all of you who came today and asked questions and actively listening. Your presence and engagement truly made this event meaningful. And thank you all for coming today. And Mr. Siddhicha, I would like to invite you to the stage. We have we will take a quick photo, and we have refreshments for you all. We can have them as well.